Hi, I'm Mojtaba. In this tutorial, we're going to understand de novo's decision-making logic for choosing between the happy path and the non-happy path. So, in the previous episode, we figured out where in the de novo code it decides to go down the happy path. Now today, we just need to generate 3 traces from that point to understand the decision logic. 2 traces for the valid state and 1 for the invalid state. You might be wondering, why 3 traces? Well, it's pretty simple. We're looking for a value that's the same in the 2 valid traces, but different in the invalid one. The reason we have 2 valid traces is to cancel out any randomness. As you may remember, in the valid state, the program set this value to 1 here, which is essentially the 0 flag. Now, let's change the username again to go into the non-happy path. So now, with our simple tool, we wrote a function to check the values. You can see exactly what I just described here in C++ code. I actually asked AI to write all this code for me. As you can see, it found a bunch of values for us. I'll just check the last one. And like I said, we were looking for a value that's the same across the 2 valid traces, but different in the non-happy path trace. It's really interesting. If you look closely, it looks similar to the game token structure, or starts with A. And as you can see, this structure exists way before the game token is even read. Now we need to make sure that the decision is actually being made based on this value. So let's just change the value and see if the program's behavior changes. And as you can see, now that we've changed it, it goes into the non-happy path. So this value is probably some kind of fingerprint tied to the username. We need to check whether this value also changes when the username changes. And you can see, when we change the username, this number changes too. In future episodes, we'll try to gather more information about the fingerprints that Denuvo collects. Thanks for watching so far.